today's new lesson. First of all, let's do a couple of bell work problems. So in the first two problems, we're going to need to grab us a calculator. So let's get your calculator out. Now, the calculator I'm calling up is an online calculator, so it will work a little bit differently than the one you're going to be using from our class, and so just kind of keep that in mind. So on the first one, I'm going to find the square root of 108. So in this particular calculator, I actually type in the number first and then hit this button, which is my square root key, and it tells me that the answer is 10.39 with this big long decimal. Well, it turns out that they want me to round it to the nearest tenth. So the 3 right here, right behind the decimal, is the 10th digit, and the 9 will make that 3 become a 4. So I want to write down 10.4 for my answer on number 1. For number 2, we'll take a look at our calculator once again and clear out the initial value. Now we're going to put in the number 68, find the square root. Again, we're going to round to the nearest tenth, and so we're going to look at that 2 right there behind the decimal and realize that that 4 does not change the 2. So my answer on this one is going to be 8.2. All right, on these next two problems, we're asked to write in simplified radical form, and we're just going to basically simplify them the way we were doing on our most recent assignments. So 118, I realize I can divide that by 2. Divide it in half because it's an even number. When I do that, I end up with the number 59. And lo and behold, the number 59 is a prime number. So if you stop and think about it, that is as far as we can go with that number. It won't simplify any further than that. 59 won't break down into anything smaller than 59. It's a prime number, so that was a very unusual radical. All right, let's try this next one. This one looks like it will simplify. We've got 5 times 25. That breaks down further into 5 times 5 times 5. So if we circle our pairs, we got a pair of 5s there. One of those will come out front. Then we'll have our radical sign, and underneath the radical will be our leftovers, which in this case was the number 5. All right, so there we go. Now we're going to talk about what we call the Pythagorean Theorem. And in order to actually apply the Pythagorean Theorem, we needed to know how to do square roots. So the Pythagorean Theorem is a theorem that deals with right triangles. You'll notice that right triangles have certain common characteristics. First of all, they have a right angle in them, which is the little box down here in the corner. They have 3 sides. The 2 sides that attach to the right angle are called A and B, or they're called legs in some cases. And then the side that is across diagonally from the right angle is called the hypotenuse. And then the letter we usually associate with the hypotenuse is the letter C. And we'll show you shortly why we use those letters. Now, there are a couple of great videos that deal with this Pythagorean theorem, and I would invite you to watch both of those if you're sitting at home or whenever you get a moment. If you're in class, go home and watch them later on. They are just excellent videos about how the Pythagorean theorem works. Essentially, what it comes down to is this. For a Pythagorean theorem, if you look at the 3 sides, A, B, and C, if you make a square with the same lengths as those lengths on that triangle, which means that you're going to square the number A and square the number B and square the number C, you will get a value which represents the area of that square that size. If you take those numbers, A squared plus B squared, it turns out that they equal C squared in every single right triangle, which is a rather dramatic and important finding. So what we're kind of saying is that the leg A squared plus leg B squared equals the leg C squared. They actually literally are the same amount. Pretty amazing. So let's try it. We've got an A, a B, and a C here. So let's write this out. So now let's look back at our previous slide. We've usually been calling the letter that goes up and down, or that side A and then the bottom B. It doesn't matter. They're kind of interchangeable, but we'll call this A and for our examples purposes. So we'll grab our markers, grab a color. And A is the one going up and down, so 12 squared plus B squared, which is 5 in this case, 5 squared equals C squared. And then 12 squared, what does that equal? Well, that's 144. And 25 squared is 25. So 144 plus 25 is going to equal C squared. 144 plus 25 is 169. And all of that equals C squared. Now, you'll recall from previous lessons that in order to unsquare something, we have to take the square root. So I'm going to take the square root of both sides of this inequality, or this equation, and C squared will just become C. And 169, so the square root of 169 will be the value we're looking for. So let's grab our calculator. 169 square root. Turns out that it's 13. So our number there will be 13. So that's how you do a problem using the Pythagorean theorem. Let's jump right along into another problem. Let's try this one. So we've got two legs, A squared and B squared. So A squared plus B squared equals C squared. And 4 squared is 16. 4 more squared is 16. And all of that equals C squared. Now what is 16 plus 16? Well, that's 26, 27, 28, 29, 31, 32. If you add those two together, you get 32 equals C squared. Now to find C, we have to take the square root of both sides of our equation so that we get right down to just the letter C equals a number. So let's grab our calculator. 32 square root is 5.65, and I guess we'll round it to the nearest tenth as well, so that would be 5.7 in this case. 5.7. All right, let's try a couple more. Now, sometimes we might actually reorient the triangle so it looks a little more confusing, but not to worry. We know that the two sides that are adjacent to the right angle here, those are the legs. So one of them will be A, one of them will be, and it doesn't really matter which one it is. So we're just going to square them both and add them together. So let's just say A squared is 7 squared plus B squared, which is 4 squared. And all of that equals C squared. All right, so 7 squared, 7 times 7 is 49. 4 times 4 is 16. And 49 plus 16 is 59. 60 plus 5 more, so it's 65. 65 equals C squared. How do we find C again? Take the square root of both sides, and we end up with C equals, and so we got the square root of 65. Grab our calculator. 65 and square root 8.062257, so round to the nearest tenth. So that will just be 8.1. All right, so far this is looking pretty straightforward. All right, we got another one over here. Let's try that one right there. So a squared plus b squared equals c squared. All right, so if we do that, then 10 times 10 is 100. And 5 times 5 is 25. And so 100 plus 25 equals c squared. Or you've got 125 equals c squared. Now to find c, we got to take the square root of both sides of our equation. And we end up with c equals, and we're not quite sure what the square root of 125 is, so we got to do 125 on our calculator and square root, and that's going to be 11.2 if we round it to the nearest tenth. 11.2 would be that particular calculation for this side C. Now you notice that in each case, the hypotenuse is always longer than either of the legs is. Okay, we've got a couple more for you to try out, so you can hurry and try that on your own desk. And then I'll write them out here as well. So we're going to have a squared, which is 10 squared, plus 5 squared equals c squared. And 10 times 10 is 100. 5 times 5 is 25. And all of that equals c squared. All right, so what do we do to get c? Well, first of all, we add 125 to 100 plus 25, we get 125 equals c squared. And then we take the square root of both sides, like this, to get c by itself. And then the square root of 125, according to our handy-dandy calculator, 125 square root would be 11.2. All right, so there's a few square roots. I think we've seen enough. We can skip this one. Let's go on to the next one. Well, what we've got is we've got an ALEKS assignment entitled Pythagorean Theorem Solved for the Hypotenuse. So in this particular set of problems, you're only going to be solving for the hypotenuse. In future assignments, you could be solving for one of the legs or one of the shorter sides, which is a little different than what we just got through learning about, but it'll still be just as easy, and we'll get to that in our next lesson. Thank you very much.